Thank you very much for the introduction. So I'm gonna talk about neglected invaders, more specifically about Neocaridina and its parasite in Central Europe. Well, let's start by saying that freshwater ecosystems are heavily impacted by human activities and environmental changes. You have pollution, habitat alteration, habitat destruction, invasive species, and all this usually leads to a loss of biodiversity, which is then further exacerbated by climate change. But today's topic is biological invasion, so I'm going to focus on that. The release of invasive species, also the release of aquarium pets, usually increase the impact of invasive species on the environment. And this is quite important because the release of ornamental pets can have direct and indirect impact on the recipient community. So the direct impact are usually competition, predation, or parasite transmission, pathogen transmission. But the release of ornamental pets can also alter habitats or alter water quality, as you have seen before when Rafael presented the problem related to crayfish. And I must say that not all the aquarium pets which are released in the nature become invasive. So most of them are restricted by their physiology. So the environment where they are released, it's not suitable for them. But this is sometimes not true for species which have high environmental plasticity. So they are able to tolerate a lot of different environments, and they are able also to reproduce very quickly, like Neocaridina davidi. And Neocaridina davidi, it appears that it's able to also adapt to colder climate over time. Neocaridina davidi, it's one of the most common shrimp in the aquarium trade. I think all of you know it, but it comes from Southeast Asia and has established different population across the world in different countries. Some of the countries, like Canada, you might ask, oh, what they are doing there? Like it's pretty cold. Well, they are in thermally polluted water, and that's why they are able to stay there. But what is important here to know is that Neocaridina davidi, it's not a tropical species. So in their habitat of origin, the temperature can range between 6 degrees in the winter and 30 degrees in the summer. This is still a temperature that it's between 2 and 4 degrees higher than the temperature that we have in Central Europe in the streams, because streams in Central Europe which are not affected by thermal pollution are colder than that. So at the moment, the presence of Neocaridina davidi in Central Europe, it's a bit restrained to like thermally polluted water. But it's important also to know that Neocaridina davidi, it's a host for several pathogens. And pathogens like Microsporidium, which are an intracellular parasite. So they are super small. We cannot see them. We can only see them with microscope. And this parasite can be specialist or generalist, which means that specialist parasite is only able to infect one host, so one species or very few species, whereas a generalist is able to infect many different species. And this is really, really, really important, because if Neocaridina Davidi that are infected with a generalist parasite are released in the environment, it's possible that this parasite is going to infect also native species. And therefore, we, together also with Rafael, we decided to look at different population of Neocaridina Davidi in Europe, in Central Europe. And we investigated 2 river catchment in Germany, 1 artificial channel in Poland, and 1 thermal creek in Slovakia, and 1 thermal creek and 1 thermal pond in Hungary. All the Neocaridina were collected along temperature gradient, and we found them usually in water that were ranging between 9 and 29.3 degrees. So quite a wide range. But I know that Neocaridina have been observed, especially in Hungary, also in colder water, in 6-degree water, which is quite impressive. And I also have to say that I found female with eggs at 9-degree temperature, so which is a bit lower than what we might expect. But since we were also interested to see if the parasite that Neocaridina Davidi have can be transmitted to other species which are living together with them, we also collected 8 amphipod species, include native and invasive one, Azellus aquaticus, which is an isopod, and Procambarus clarki, which is a prominent invader, and Rafael just talked about it. So, and beside that, I also wanted to look into the origin of parasites that we find in Neocaridina Davidi. So we bought shrimp from the pet trade, and then I analyzed them for parasite. The type of analysis that were conducted during this study were molecular analysis for both crustaceans and for the parasite. But since we wanted to be sure that Neocaridina Davidi is actually infected with the parasite, we conducted also histological analysis. So we slice it in tiny slice, the Neocaridina, and then we colored them, and then we looked at the microscope. And when conducting molecular analysis, we said, oh, maybe different Neocaridina have different thermal tolerance. They are able to stay in colder or warmer water, depending where they come from. So I looked into all the genetic data that are available online to see where the different Neocaridina in Asia, cluster in Asia. And as you can see here, there are 3 groups. So you have Neocaridina belonging to the clade B1, one group that it's in the southern part of Asia, which is the original, let's say, Neocaridina, where the Neocaridina come from. And then we have 2 groups in northern China and in Japan. In Japan, it is invasive. In northern China, we are not really sure at the moment, but they differ also genetically. And therefore, when I looked into the Neocaridina that we get from the pet trade, and I saw that all belong to the B1. So it's everything coming from basically Taiwan, as most of us already know from the pet trade, but still it's just confirming that. And then I said, okay, we can have a look, since Neocaridina have parasites, since Neocaridina seems that they are expanding toward colder water, how it's going to be in the future. Can they expand in more places or not? And for this, to know this, we constructed model with computer model to simulate or predict how which habitat are suitable for Neocaridina, for northern population and for southern population, because the climate where they live is very different. And then we predicted how it will be in the future, so 2050, and we tried to project this onto Europe. And yes, so I will come to that a bit later, but let's first look into the parasite. So we find 3 new populations of Neocaridina davidi, which are now established, that's confirmed, and they had several parasites. And among them, there was also Encytonucleospora hepatopenae, in short EHP, which you can see in this circle. You can see the spores which are indicated there in the middle, and that's the hepatopancreas of Neocaridina. So we were able to confirm that Neocaridina is a definitive host for this parasite. But why this parasite is important? Because it's a parasite that it's of marine origin. It's not a freshwater parasite, but can still live in freshwater. In fact, animal in freshwater. But in freshwater, it's not so infective as in marine water. And this parasite comes from a shrimp farm in marine water and in coastal water from Asia. So this is the first time we actually found this parasite in Europe. And it's a parasite that causes a lot of problems, especially in the fish farming industry, in the shrimp farming industry. It's really, really a problem in Asia. But it's also, besides having this economical impact, it also has an environmental impact, because it is a generalist parasite and is able to infect different animals. We know that it's able to infect Procambarus clarke, it's able to infect dragonflies, so not only crayfish, not only shrimps, but also other animals. And it has been found in mollusks, in small worms, everywhere. So we don't know if all of these small organisms are also hosts, but still it's quite scary. Like, it's a parasite that can spread. What can happen in our river if this parasite spread? We don't know. So it's important to know that it's here and need to be monitored. But then we also find 2 other microsporidium parasites. And among them, one of these microsporidium was also found in Procambarus clarke, which is the first evidence that parasites that are infecting Neocaridina can also transmit to other species. And this is important because, as I said, if Neocaridina is spreading, more parasites are spreading. And this is the result of this computer model. So what came out, and you see there is a lot of difference between the southern population of Neocaridina davidi, which live in a climate that is warmer, compared to the northern population, which are just below that. But this model worked quite well because, as you can see in the upper left picture, you see a red dot. This red dot, it's a population that is living in Israel since several years, and it is like fitting. So it's a mathematical model, but it works. So if we think that Neocaridina davidi it's able to, at some point, adapt to different temperature the same way as the northern population of Neocaridina Davidi, then we can expect a scenario like this, that it's going to develop in this way in the future. So we can expect that most of Western Europe, it's going to become suitable for Neocaridina Davidi, but a large part of Central Europe would be spared from that, possibly. So the increase of the presence of Neocaridina Davidi in Central Europe, but also an increase in salinization in the river, because many rivers are becoming more and more salty. This might boost really the spread of this parasite. So we might find this parasite in the future in many different native species. And I have more bad news, actually, because a few months ago, I got in contact with colleagues from southern France, and they found a new population of Neocaridina Davidi. And I started to analyze this population, and what I found out is that they have the same parasite that native species like Gammarus pulex and Azellus aquaticus have, which is like, okay, so there is parasite exchange. But how many of these parasites are coming from Neocaridina Davidi, and how many are coming from native species? We don't know. So I will do more field work later on this year to find out if more parasites have been introduced together with Neocaridina Davidi or not. But it might also be interesting if these parasites are native parasites, because it might be that native parasite might reduce the ability of Neocaridina Davidi to spread. And last month, I was in a small island between Madagascar and Mauritius, which is the island of La Réunion, which is a French overseas territory. And I was sampling Neocaridina Davidi. As you can see, this nice stream, like full of Neocaridina Davidi, like a red carpet on the bottom. Crazy, completely crazy. And they are also infected. But they are infected with diving beetle parasites, which is also like, okay, so we start to see a lot of different things that can infect Neocaridina Davidi, but what is then the impact on this environment? It's crazy. So thank you very much for your attention, and as a last message, I will just ask you, please don't release your shrimp in the environment, because they might really cause a lot of trouble. Thank you very much, and if you want to hear more about or get update on these topics, that's my Twitter or X account, and you can just follow it. Thank you very much. If you have questions, please feel free to ask. Sorry. I know unofficially that they are infected as well with this parasite, but officially they have never been checked for that. But I know they are infected, and with Encitonucleospora hepatopenae, actually. I found also documents from the veterinary office in Taiwan, and they found it, but they didn't want to release this information because they were afraid that they will lose the market. Yeah. But this was found in almost all Caridina, Neocaridina, yeah. So, yeah, we can check Caridina as well. That's fine. But you don't find, the thing is, you don't find Caridina in, so Caridina cantonensis, it's too sensible to water parameters, and that's why normally you don't find it in nature, because it's not able to survive there. It's not so flexible like Neocaridina is. And that's why I didn't focus much on that, because it's not a big problem in that sense. We found like Caridina babaulti, like some years ago, but not cantonensis. Okay.
Kliknij w jeden z polecanych filmów, aby obejrzeć najlepsze produkcje kanału Chopin's Shrimps.